Hello, everybody, and welcome back. Chapter 8. This week we'll ask you to read Chapter 9 on your own, make your own notes. But we're going to focus on Chapter 8. It's a super exciting chapter. It's going to list a lot of rules and whys and why nots. That's really key to your policy success because we've got to know after policy what standards and controls that we want to emphasize. And so, communication security and operation security are going to focus on that information technology, right? Including standard operating procedures, change management, and quality assurance become absolutely essential. Malware protection should be addressed, data replication, secure messaging, and activity monitoring like logging. So many companies are going to outsource these functions, but if they do, we'll talk about other issues that you should address in policy later in this chapter. So, the SETA, which is the Security Education Training and Awareness Model, we talked about that in Chapter 6. It is particularly appropriate in this process. So, data owners should be educated on the operational risk, and data custodians, again, focus on the operational security threats. Remember, data owners decide, data custodians do. Okay, so these are objectives for this week. So we'll start with standard operating procedures. Standard operating procedures are detailed explanations, detailed on how to perform a task, right? And an SOP is providing that standardized direction. It improves communication. It reduces training time and improves work consistency. So many great reasons to do an SOP. If you refer back to the hierarchy in the first week of class, right? And so an alternate name for SOPs is Standard Operating Protocol. Some of you may have heard of that. And basically, we're analyzing in detail who, what, where, when, and how something should be accomplished. So an SOP should be written by individuals who are knowledgeable of the activity and apply some detail to the activities that they're writing about so that they can create this step-by-step communication guide. And well-written SOPs reduce then our organization's dependencies on individual and institutional knowledge. If somebody quits, gets fired, leaves, takes time off, we can continue to function well without them. So we want to make sure that we authorize the SOP documentation by having as we're writing it, a series of reviewers. It should be readable for clarity. It should be verified by testers. And the process owner is the one that is responsible for authorizing the publication and distributing it amongst so many. Now, the now this may seem like a small thing, but it actually comes up quite a bit. So at a location where I worked, an individual wasn't doing well over many years, and they were getting ready to terminate the individual. They were the only one that had control of the console that managed the wireless access points. And so the concern was that once they are let go, do we have all the passwords that we need, right? This really should have been clarified earlier by creating in the policy and the standards and the controls due diligence, a sharing of controls, right? That sort of thing, right? There are things in hindsight we could have done using policy. So, in developing SOPs, then we want to use a plain language approach in this process, right? And there are four basic SOP formats that we'll talk about. There's the simple step, hierarchical, flowchart, and graphical. And you see a good explanation of that in page 220, 221, 222, and following of the book. But notice that table 8.1, which is something that really does summarize it in a nice way, and it shows the best way to write and list SOPs in that simple step, right? So if you have more than 10 steps, if you don't, a simple step approach might be the kind of SOP to use. If you do have more than 10 steps and no major decisions are going to be made, a hierarchical or graphical approach is really probably the way to go. If you want to use a flow chart, well, if there are lots of decisions to be made and there are no more than 10 steps, but you have decisions to be made, a flow chart is good. But even if you have more than 10, it's about decisions. If a lot of decisions are going to be made, flow chart is really a great way to go. The simple step process is really about routine procedures, right? There's no decision making, and they're really just kind of rote procedures. Where the hierarchical format is about a long procedure. So it's going to have much more detail with sub-steps required. And again, anything greater than 10 steps with little decision making is how I would use that. Now, the graphical format is shown on page 223 of the book, and it really is a good representation, and it's often used to configure tasks. And if you have people with varying levels of language, we're working with companies in China and India and elsewhere, sometimes the graphical approach communicates nicely. It's all about communicating and getting the work done in a consistent, standardized, repeatable, and controlled fashion. And then, of course, so an example of the graphical format, as I said, is on page 223. And it's used to configure tasks, especially, again, with the language or literacy issues. Say you work in a company that you have somebody out of high school doing your tasks, right? You want to make sure that, because they don't speak on your level. And then the last one I mentioned was the flow chart, right? And the flow chart is used for procedures that require, as I mentioned, many decisions, right? And if you do use a flow chart, you want to make sure that you use the accepted flowchart symbols. ISO lists them. ISO 5807 colon 1985 will list SOPs. And the book even mentions at the bottom of page 224 a recommended source for learning how to write procedures. It's called the Procedure Writing Principles and Practices, and you can refer to that. Highly recommended. Because all this is meant to ensure secure operations in the information systems. Now, let's see. We've kind of already summarized this slide and finished up. I kind of got ahead of myself with the SOPs. So moving on to operational change control. Operational change is inevitable. If there's one thing that's certain in life anymore, it's change, right? So change control is an internal procedure that is going to ensure the stability of our network while maintaining the required levels of CIA. So a change management process establishes this orderly, effective, repeatable, standardized mechanism using subject matter experts that evaluate, approve, prioritize, schedule, communicate, monitor, and accept the risks with change, right? And so why manage change, right? It's probably the most important part of the book, right? This chapter, frankly, almost is, but change control really is, right? Because change control, managing it presents risks to ongoing operations, and anytime we make a change, right? And the data that are effectively mitigated by consistently and careful management in this process. So consider this scenario, for example, right? Windows 8 is installed on a mission-critical desktop or workstation. And so the system administrator installs a service pack. And of course, we've learned in other courses earlier that a service pack will often make changes to file systems. That's why you install it. And now imagine, for a reason beyond the installer's control, that the process fails halfway through the service pack update. Bam! What's the result of that, right? So an operating system that is neither in the original state now, nor in the updated version, right? Will that create an unstable platform? And if so, what would be the impact, right? And so it can be quite significant. Now imagine that if this machine were a network server, not just a workstation, right? And it's used by all employees all day long, right? We may have just created our own DDoS, right? Or denial of service attack. So if the failed change impacted the customer facing device, then what's the impact, right? Uh, like uh, uh, we had a gentleman once who made an unauthorized personal change that impacted. I worked at an internet service provider, and it shut down the internet to over 20,000 regional businesses. Imagine businesses that are trying to swipe credit cards. If there's one rule of change, you do not interrupt order to cash, from the customer making the order to the business receiving the cash. Do not interrupt that process. That gentleman, unfortunately, super guy, was escorted out of the building within hours, right? And so change needs to be controlled, right? The change control process starts with an RFC change, that's a request for change, and then it's submitted to a decision-making body, which usually has all these subject matter experts on them. And then at each step, you want to document it, right? And IT, which should really run this kind of discipline, and QA representatives, and the subject matter expert doing the change ticket should always be on it. And so the process, of course, will vary. And I added, when ran change control, I added a peer review as a requirement prior to going to the change board. And I also added categories of changes. So a process for emergency changes, a process for standardized changes, and normal changes. That's how I defined it. You could, of course, do your own. And then we want to make sure our control plan is developed and implemented as needed, right? So we want to make sure we have a a dev environment, then test our change in a UAT environment, which simulates production, but it isn't production. And then we want to do change control and then drop it into production. In fact, when I meet the change control board, I want to make sure that dev and UAT have been tested and the results have been peer reviewed. At that point, I will approve the change. In fact, even then, I'm not really done. Once it's in production, for the first 24 hours, I am monitoring its activity specifically to make sure that it's functioning well. So we want to include it as well in all of this, make sure that security is involved on that change control board to ensure that new vulnerabilities aren't being introduced, right? That we always in a change control process want to have a rollback plan, right? And a recovery options, and I mentioned post-implementation options. There's some other rules in change control you could consider. I would never do a change, since we had weekends off, largely. I would never do a change on a Friday or a Saturday. I'd do them last one on Thursday so I could monitor it 24 hours. And then I would do it Sunday night and then monitor it on Monday, that sort of thing. And of course, whenever we have change, we want to communicate it and then implement it. I always had, as a standard procedure, a bridge stood up, ready to go. If there was ever an outage based on what may or may not have been the change, go to the bridge. We know who's going to be invited from all the disciplines, and we're working together quickly to resolve the issues that can develop. Okay, that's a good place to break. We're going to come back with patching in the next section.